Hi, everyone. So today we're going to be talking about excess acids or bases. In the last set of notes, we talked about neutralization reactions. And basically, what happens in a neutralization reaction is we have the moles of the hydroxide ion OH minus equals the moles of the H plus or protons in solution. So, because those moles are equal, we get a pH of 7 because they kind of cancel each other out, and therefore we have a neutral solution. Now, in this case, what we're going to do is we're going to have a solution that has either more acid or more base. So it's not going to be like the same amount like we talked about before. So the pH of this reaction will be determined by the excess reactant. If we have more acid, it will obviously be an acidic pH, so it'll be below 7. If we have more base, it will be a basic pH, so it will be above 7. And that will just depend on the number of excess moles of either H plus or OH minus. That will give us our pH of solution. So I'm just going to jump into two examples here. This is a 4-step process. And so I'll go by step with each example, and it will make more sense if we just jump into some examples. So our first example here is when 15 milliliters of 2 molar, and this is sulfuric acid, is combined with 15 milliliters of 3 molar sodium hydroxide. We want to determine if the solution is acidic, basic, or neutral, and we want to calculate the pH. So the steps here are: number 1, we're going to calculate the moles of both H plus ions and OH minus ions. The second step is we're going to find the excess reactant by subtraction. The third step is we're going to calculate the new molarity of the excess reactant. And then the fourth step is we're going to use the molarity to calculate the pH or pOH. Obviously here I'm asking you to calculate pH. So if we have a, excess base and we can find the pOH, then we would subtract that from 14 to find the pH. You'll see more of what I mean in the next two examples. So let's go through step by step. So our first step is we want to calculate the number of moles of both our H plus ions and our OH minus ions. So we know that the number of moles is going to be the molarity of the solution times the volume of the solution, or multiplied by the volume of the solution from our molarity equation. So we get the molarity of the acid times the volume of the acid, and then obviously times the number of hydrogens in that solution, because we can see here that if I have 2 hydrogens in this sulfuric acid, when this dissociates, I'm going to get 2 moles of H plus for every 1 mole of this thing. So that's why I'm going to multiply it by 2 for that. So I get 2 molar sulfuric acid times 15 milliliters, because that is our volume of solution, times 2. Now, you might be thinking, Mrs. Stewart, why don't you change this to liters? Because when we're talking about a molarity, that's moles over liters. Now, you can change it to liters. That would be 0.015 liters. I'm going to keep it like this. And basically what I get here, instead of moles, I get millimoles. If I keep all my volumes in milliliters, I'll end up with molarity at the end. So those kind of milli units are going to cancel out. You'll see what I mean in a bit. All right. It's just easier. I think the numbers are easier to handle if you just keep it in milliliters. But remember, all of your volumes need to be in milliliters. So what I'm getting here is I'm getting millimoles because I have milliliters. So doing this math here, I get 60 millimoles of H plus. Okay. Now, next I want to do the base. So I get the molarity of the base times the volume of the base times the number of hydroxides in that base. So my base was a 3 molar sodium hydroxide solution times the volume of that base, which is also 15 milliliters, and then multiplied by 1 because I only have 1 hydroxide in that base. So doing this math in my calculator, I get 45 millimoles of hydroxide. So now I can already see I have more hydrogen ions, H plus ions, than I do hydroxide ions. So I already know I have an excess of those H plus ions. So therefore, this is going to be an acidic solution. I already know. I can already answer this first question, determine if the solution is acidic. It is acidic. All right. It's not going to be basic. So my second step here is I want to find that excess reactant by subtraction. So what I'm going to do is I'm just going to subtract 60 minus 45. So I get 15 excess millimoles of hydrogen ions. Third step is I want to calculate the new molarity of the excess reactant. Now again, molarity is number of moles over number of liters, or in this case, because I have millimoles, I can put that over milliliters, and then I can find my new molarity. However, one thing we have to take into account here is that our volume has changed. It's not 15 milliliters anymore because I've added two 15 milliliters together. So now my total new volume is 30 milliliters, all right, because I've added a 15 milliliter acidic solution with a 15 milliliter basic solution together, and I get 30 milliliters total. So that's going to be my new volume. To find the molarity, again, like I said, it is moles over liters or millimoles over milliliters. And then plugging my numbers in here, the molarity is going to be 15 millimoles because that was my excess number of millimoles of H plus over my new volume of 30 milliliters. And I end up getting 0.5 molar H plus. So this is the concentration of my hydrogen ions in solution. Now, the fourth step, last step, is we're going to use the molarity to calculate the pH or POH. So here, the question asked for pH, and I have my concentration of H. So all I'm going to do is use the pH equation. So I get that pH is equal to negative log of the hydrogen ion concentration. Plugging that 0.5 molar in for my hydrogen ion concentration, I get negative log 0.5, which ends up being 0.3. So that is my answer to the question. All right, one more example. We have determine the pH of the solution. Do I have a, yeah, there's something under there. Determine the pH of the solution formed from combining 80 milliliters of 0.3 molar HCl and 75 milliliters of 0.4 molar NaOH, sodium hydroxide. All right, so we are going to go through step by step one more time. So number one, I'm going to calculate the number of moles of H plus and moles of OH minus using our molarity times our volume times the number of hydrogens or the number of hydroxides, just like we did before. So step number one, for starting with acid, we get the molarity of the acid times the volume of the acid times the number of hydrogens. The molarity of the acid was 0.3 molar. That was my hydrochloric acid. And then the volume of the acid was 80 milliliters, and then times 1 because it's hydrochloric acid, so there's just one hydrogen in that acid. And so 0.3 times 80 is 24 millimoles of H plus. Again, I'm keeping it in milliliters, and therefore I get millimoles here. Now for the base, we get molarity of the base times volume of the base times number of hydroxides. So molarity of the base was that 0.4 molar sodium hydroxide. The volume was 75 milliliters of base. And then in that sodium hydroxide, again, I only have one hydroxide, so just multiplied by 1. So we get 0.4 times 75 is 30 millimoles of hydroxide. So here we can see that we have more hydroxide than we have hydrogen ions. So therefore, this is going to be a basic solution. So now we're going to subtract moles to find the excess. 30 minus 24, I have 6 millimoles of excess hydroxide in my solution. And then we need to calculate the new molarity. Of course, before we do that, we have to find the new volume. So I had a volume of 80 milliliters and then plus 75 milliliters for my total volume. So that ends up being 155 milliliters for my new volume. And then molarity is moles divided by liters or millimoles divided by milliliters. So we end up getting 6 millimoles of excess hydroxide divided by our new volume of 155 milliliters. So for our molarity, we get 0.039 molar. So that's the concentration of hydroxide ions in solution. Again, because the thing that was in excess was hydroxide ions. Now from this, I know that I want to get pH, but I can't directly get pH from the concentration of hydroxide. So first I need to find POH. So my POH I know is the negative log of the hydroxide ion concentration. So plugging this in here, we get negative log of 0.039, which ends up being 1.4. And then I know that pH plus POH equals 14, so I can use this equation to find my pH. So my pH is going to be just 14 minus my POH, 1.4, and so I end up getting 12.6 for my pH, which makes sense, right? Because I have an excess of hydroxide, so this should be a basic pH. So that was my two examples for my excess acid or base. If you have any questions, please let me know. Good luck on your checkpoint, and I will see you in class.